Hello, listeners. Now we'll be continuing with our topic of motion along a straight line under kinematics. And we had discussed earlier a few terms which I'll be just introducing to you once again. That is distance between two positions, displacement, again, shortest distance between two given points from the initial to the final position, speed, that is the rate at which an object is moving from one point to any other given point, and finally velocity, also having direction involved in it. It also gives the rate of motion. So the distance and speed, as we had discussed earlier, are scalar quantities, have magnitude and do not mention the direction or do not involve the direction, while the displacement and velocity are vector quantities because they involve direction along with the magnitude. So these are the terms that we had discussed thus far. We shall further proceed into new terms and new discussions into the topic. So some of the new terms that we will be discussing right now, the latest being the acceleration. As you can see, the symbol for acceleration is a with a vector quantity. It is a vector quantity that is represented by an arrow, and it gives a measure of how a given body accelerates. Now what do you mean by the term accelerates? It means just speeds up, how a body speeds up, at what rate is a body speeding up, at what rate does the given body increase its speed. Now when we are considering the rate, the word rate over here is important. Yes, because the rate involves time, how much time it has consumed to increase its speed. So a body is said to have accelerated, right? It is said to be accelerated if it has changed its speed or if it has changed its velocity. Now velocity, because acceleration is a vector quantity, so velocity is obviously involved over a given interval of time. So it's said to be accelerating if it is changing its speed or velocity over a given interval of time. Now mathematically, acceleration is the ratio of the change in speed or velocity of the given object to the time taken for that change. Ratio of the change in speed or velocity to the time taken for the change. Now all these terms that you can see are ticked are very important to understand the definition. Now if I am writing a vector within a modulus sign, that is by 2 bars that is given besides it, that means we are considering the magnitude only, right? We are not considering the direction over here, which is the case in motion in a straight line because it is moving in a straight line, so we need not consider the direction as much. So a vector modulus means the magnitude only, although it is a vector quantity, is equal to the change in speed or velocity divided by time taken, and there we have delta v by delta t, where delta represents the change. Now a vector mod is equal to delta v by delta t or delta v vector by delta t. Now let us consider an example which will help you understand it better. Suppose a body changes its speed from 4 meter per second to 10 meters per second in 3 seconds. What is its acceleration? A simple answer based on the equation only. So what is the change in speed over here? Delta v. That is how to calculate the change in speed. That is the final speed minus the initial speed. So final speed is 10 meter per second minus the initial speed is 4 meter per second, or was 4 meter per second. So the result is 6 meters per second. So this is the change in speed. Delta v is equal to 6 meters per second. Now what is the time taken? As it has said, the time taken delta t is equal to 3 seconds. Now it can be from 7 seconds to 10 seconds. So the timing was not given. So it has just directly put the change in time, that is 3 seconds. So it was easier for us. So we need not subtract any time from any other time. So acceleration here is equal to, we are considering the modulus again, and modulus we need not write the vector every time. So a is equal to 6 meter per second, that's the change, divided by 3 seconds, that's the time. So 6 by 3 is 2 meter per second square, which is the unit of acceleration. So what is the dimension of acceleration now? Obviously it is L t to the power minus 2, or m0 L1 t minus 2 in powers. Now we move over further into the topic where we consider the speed, the velocity and the acceleration. Now consider these three terms. Now we will further categorize these three terms here: speed, velocity and acceleration. They can be further categorized under two cases, that is the average and the instantaneous. Okay. Now average speed, instantaneous speed; average velocity, instantaneous velocity; and similarly we have average acceleration and instantaneous acceleration. So let us consider the first of the lot, that is the average case. What are these things, average and instantaneous? So average speed. Okay, so how do we represent it? By suffixing an AV with that V. So V average, VAV. If we know that speed is equal to distance traveled by time taken, that is V is equal to S by T, then average speed, that is VAV, is equal to total distance traveled divided by total time taken. The two words that have been introduced are total in the numerator and denominator. What does that mean? It can therefore be defined as the ratio of the total distance traveled by a given body, okay, to the total time taken by it, right? Now mathematically we can also put it as V suffix AV is equal to delta S by delta T. Delta, as I had told you, is the change, and here delta S is the change in position from one point to another point, and delta T is the time. Yes, we box it up so that we can remember. I'll give you an example for better understanding. A man walks to the market, which is 5 kilometers away from his home, in 1 hour. He then returns back to his home in 1.5 hours. Calculate his average speed. So he went in 1 hour, he came back in 1.5 hours. So different timings. So we'll be getting the answer now. So H stands for home and M for market. So between home and market the distance is 5 kilometers. 5 kilometers for going and 5 kilometers for coming, obviously. So while going he takes 1 hour. He was energetic, and from the market he got tired probably and took half an hour extra. So while returning he took 1.5 hours for the same distance. So the total distance he traveled is equal to 5 kilometers for going and 5 kilometers for returning, that is 10 kilometers, and total time taken is 1 hour while going and 1.5 hours while returning, so that is equal to 2.5 hours. So as per our definition of average speed, V average is equal to total distance traveled, that is 10 kilometers, divided by total time taken, that is 2.5 hours. So what is the speed now? That is equal to 4 kilometers per hour. Again, average velocity. Now that was speed and this is velocity. As you can see, we have a vector sign over there, an arrow over the top. So it is the ratio of the net displacement to the total time taken. There it was the total distance by total time taken in case of average speed. In average velocity, it is net displacement by total time taken. So V average vector is equal to delta S vector by delta T. The vectors obviously represent the vector quantity, the arrows. So delta S here is the net displacement and total time taken is delta T for that net displacement to take place. Now consider that formula that I have given you. If I introduce the modulus over there, then in the modulus form we only consider the magnitude of the given vector, right? There's no need to consider the direction here, only the magnitude. Usually this is the case that is considered for motion in a straight line, where we require only the magnitude. The direction is not required if it is not given in the question. Now take that same example that we had taken for average speed. Now here again, from the home to the market the person moves in 1 hour 5 kilometers and then returns back in 1.5 hours, the same distance 5 kilometers. So what is the average velocity in this case? Or we consider just the modulus of the average velocity. We just want to calculate the magnitude. Now for that we need the net displacement. Now what is the net displacement in this case? Delta S, that is. So delta S, since the initial and the final positions are the same, that is the person has returned back to his home, right? So the net displacement is 0, as we had done in the previous example, in the previous slide, that previous video that I had given you. So in this case the net displacement is 0 kilometers and the total time is obviously the same, 2.5 hours. So it is 0 kilometers per hour as in this case. So these are some of the cases that we have discussed today. We'll further move into the topic in the next class, or in the next video I should say, and I'll be giving you a few questions so that you can practice. And till then, thank you for your patient hearing. Goodbye.